this section we're going to be looking at solving for a variable. A formula is an equation that states a rule for a relationship among quantities. So we're going to look at an example right now. The formula D equals RT. As we can see in this formula, D is isolated. You can rearrange a formula like this to isolate any variable by using inverse operations. This is called solving for a variable. So first, you want to pick the variable that you want to isolate. So we're going to isolate variable R. In order to isolate R, we have to divide both the left and the right side by t. When we divide the right side by t, we eliminate both the t's, and we're left with only an R on the right side. So we get the equation R equals D divided by T. Now we're going to look at another application of solving formulas for a variable. We've been given the formula F equals 9/5 C plus 32. This is the formula for a Fahrenheit temperature in terms of degrees Celsius. But we want to isolate C, Celsius. So first we're going to start by doing the addition and subtraction. So you want to subtract 32 from the right side, and if you do it to the right side, you have to do it to the left side. So we now have F minus 32 equals 9/5 C. And in order to get rid of the 9/5 on the right side, you have to multiply both sides by the reciprocal, which is 5/9. So you're going to multiply the left side by 5/9, and make sure to use the distributive property and multiply 5/9 to both the F and the 32. And then when you multiply the right side by 5/9, the 9/5 and the 5/9 cancel out and become 1, and you're just left with a C. So your final equation should be 5/9 parentheses F minus 32 close parentheses equals C. Okay, now we're going to be solving literal equations for a variable. Our example is m minus n equals 5, and we want to solve for m. So you want to isolate m. In order to isolate m, you have to add n to both sides. When you add n to the left side, the n's cancel out and you're just left with m. So you get m equals 5 plus n. We're going to look at another example of this concept. We have m over k equals x. And again, we want to solve for m. So, no, actually this time we want to solve for k. So first we must move k to the opposite side, because k is at the bottom of the fraction. So we have to multiply both sides by k in order to do this. Because when the left side is multiplied by k, both the k's cancel out on the left side, and leaving us with only m. M equals x times k. Now that we have all the variables above the fraction line, we can isolate k. In order to isolate k, we have to divide both sides by x. When the right side is divided by x, both the x's cancel out, leaving us with just a k. And on the left side becomes m over x. So k equals m over x.